Welcome to our 4.3 video lesson. Go ahead and put today's date. And 4.3 deals with relations. So by the end of this video, our I can statement, which is our target and our goal, is that I can display relations as a table, graph, and mapping, and determine the domain, range, and inverse. So to start us off, I have a couple of definitions. Our first definition is relation. So a relation is a set of ordered pairs. After relation, we have domain, which is the set of all of our x coordinates. So if you think about our ordered pairs, in every ordered pair I have an x and a y. Domain is just my x coordinates. And if I write domain, I have to write it in order from least to greatest with no repeat of numbers. So if a number repeats, you only write it once. So if the domain is a set of all my x coordinates, range is the set of all y coordinates. And range is just like domain in that we have to write them in order from least to greatest with no repeats of numbers. Alright, a relation can be displayed as a mapping. And a mapping shows that each domain is paired with a range. And mapping looks like this right here. So mapping shows each domain is paired with a range by having two ovals. Your first oval is for your x values, which is your domain. Your second oval is for your range. It is your y values. And what it does is it shows it's pairing it by using arrows. So it says like 3 goes to 2. So that ordered pair then would be 3, 2. Then it's going 4 to 7, so that ordered pair would be 4, 7. Mapping is a lot like domain and range in that we don't repeat numbers. So no repeat numbers. If it repeats, we only write it once. And our last vocabulary word is inverse. An inverse switches the x and y coordinate in each ordered pair. So inverse switches the x and y coordinate in each ordered pair. Now on this next part, you don't have to write it out. I'm just going to show you all the different ways you can write a relation. So relation is a set of ordered pairs. So here's the ordered pairs. You get 1, 2, negative 2, 4, and 0, negative 3. You can write a relation as a table in that your x values go in first, just like the alphabet. X always comes first. So in a table, x always comes first. And if you look here, it's all of our x values. 1, negative 2, 0, 1, negative 2, 0. And then y comes second. Same way it does as an ordered pair and in the alphabet. So all my y values are here. 2, 4, negative 3, 2, 4, negative 3. Then you can take the ordered pairs and graph them on a coordinate plane. 1, 2, negative 2, 4, 0, negative 3. And lastly, you can show it as a mapping. So mapping, once again, it's 1, 2, so it goes from 1 to 2. Then it goes from negative 2 to 4, then negative 2 to 4, 0, negative 3, 0, negative 3. These are all the different ways you can display a relation. Now it's our turn to make a relation to all these different parts. So for our first example, we're given two parts. Part A says express the relation. So write this part out in your notes, the highlighted portion. The relation 3, 2, negative 1, 4, 0, negative 3, negative 3, 4, and negative 2 as a table, a graph, and a mapping. So very first thing here, I have my table. Remember, like we saw on the last page, in every ordered pair, I have an x and a y. So x comes first in ordered pair, x comes first in the alphabet. So in my table, my x value has to come first, and then my y. So we should come over here to our ordered pairs and just list out our x values. That's the only part we care about to begin with. So x is 3, -1, 0, -3, -2. So we have 3, -1, 0, -3, -2. Now keeping them in the same order that they are in up here, I do my y's. So my y is 2, y is 4, third my y is -3, fourth my y is 4, and lastly my y is -2. So I have my table. I have 1, 2, 3, 4, 5 ordered pairs up top, and then down here I have 1, 2, 3, 4, 5 ordered pairs shown in my table. So we're good. We're going to move on to our graph. And I'm going to make a 5 by 5 graph. So 1, 2, 3, 4, 5. So once you have your 5 by 5 graph up there, just go plot each point. So my first point's 3, 2. So I'm going to go right 3 because it's positive, and up 2. My next order pair is -1, 4. So -1 sends me left 1, and then up 4. Then I'm given 0, -3. So 0 is at the origin. And then -3 sends me down 3. Go back to the origin to plot my next point, which is -3, 4. So from the origin, I'm going to go left 3, up 4. My last ordered pair is -2, -2. So -2 sends me left 2, and then -2 sends me down 2. So we have our ordered pairs plotted on a graph. And lastly, it asked me to show them as a mapping. So mapping is when I have the two ovals. My first oval is my x, and then my y. As usual, x comes first. And then we're just going to come back through, same way we did our table, and say our x values are 3, -1, 0, -3, -2. And if you look inside our mapping, none of them repeat. I have +3, then -1, 0, -3, -2. So they're all different. So then we'll go over to our range, which is our y value, and say it's 2, and 4, -3. Now look, I get 4 again. So remember, I don't want any repeats. So I already have a 4 there, so I only write him once. So I don't write him the second time. And then my y last one is -2. Now to make the mapping, we're going to connect each ordered pair to its appropriate mate. So it's like the first one ordered pair is 3, 2. So I'm going to draw a line from 3 to 2. My second ordered pair is -1, 4. So draw a line from -1 to 4. Next one, 0, -3. So draw a line from 0 to -3. Then we're given -3, 4. So -3 up to 4 because it's up here. And then last one, -2 to -2. And we're good. We have our table, graph, and mapping. Now part B wants me to state the domain and range for this relation. So remember, domain is all of our x values. So I'm going to look at my domain and then make a brace for it so I know if this is the whole set of domains. And remember, we want to write domain in order from least to greatest. So we're going to look at our x values and say, what's our lowest one? Oh, -3 is our lowest x value. Then after -3 would be -2. After -2 would be -1. And then we have 0. And our last one is +3. And we close up our brace because we have all of our domain. Next, we're going to do our range. So we give him an R. And once again, we're going to make a brace. And we're going to list all of our y's out in order from least to greatest. So my lowest y, -3, then -2, and then next we have 2, and I have 4, and once again my 4 repeats, so I only write it once. And we're done. So for example 1, we made a table, a graph, and mapping, and we determined our domain and range. So let's look at our next examples. Example 2 says express the relation shown as a set of ordered pairs, then write the inverse. So we're going to have to write it as a relation. So we're given a table, and I just need to write it as ordered pairs. So my x value is 3, y value is 2. So my ordered pair is 3, 2. Then my x value is 4, y value is -1, so my ordered pair is 4, -1. My last one, I have 5, -4, so ordered pair is 5, -4. Then it asked me to write the inverse. So I have the relation, now we're going to do the inverse. If you go back to your definition about the inverse is where you switch your x and y values. So if my first order pair is 3, 2, my inverse is going to flip them and say 2, 3. So my second order pair is 4, -1, so the inverse is -1, 4. My last one says 5, -4, so I'm going to switch them and say -4, 5. So inverse flips your x and y values in each ordered pair. So example 3, we're given a mapping, and we're given our x values are 5, 7, 4, 0. Our y values are 1, 2, and -9. And we're asked to, once again, write it as a relation. Alright, so we're going to follow the arrows. My x value is 5. We follow the arrow to my y value of 1. So my order pair is 5, 1. Alright, once again we follow our next x value, and it's 7. We follow 7, it goes all the way down to -9. So that order pair is 7, -9. Alright, my next x value is 4. So I follow my 4 all the way up to my 2. So my order pair is 4, 2. And my last one is 0 to -9. So my order pair is 0, -9. And then you always go back and check yourself with a mapping and count your lines. I have 1, 2, 3, 4 lines. So that means I should have 4 ordered pairs. 1, 2, 3, 4. Now that we have our relation, we're going to write our inverse. And all we're going to do is go through our ordered pairs and switch our x and our y's. So my first ordered pair is 5, 1. So the inverse is 1, 5. My next ordered pair is 7, -9. So my inverse is -9, 7. My next order pair is 2, 4, 2. So my inverse is 2, 4. And lastly, it's 0, -9. So the inverse is -9, 0. And that's writing the relation and the inverse from a table and mapping. And that finishes up for our 4.3 notes. Thank you very much.